Good morning, everyone. Welcome. So, as you can see, my name is Costas Senekkis, and today I will be presenting mandatory access control essentials with SELinux. So, quick question for everyone. Anyone in the room that knows SELinux? Maybe, yes. Okay, so this is the objectives for today. So, we will talk about what SELinux is, the modes that SELinux operates on, the discretionary access control, and of course, mandatory access control, some SELinux policies, the labels of SELinux, type enforcements, and some quick examples on how SELinux works and how you can use it in order to protect your system. So, I'm a senior security consultant at ICSI UK. I'm leading the penetration testing team, which have been also delivered trainings for penetration testing around the globe. So, as you can see, I'm very passionate regarding Linux security. And of course, I have, let's say, a secret crush with SELinux. So, what SELinux is? It's an extra layer for the Linux operating system. So SELinux has been adopted nowadays from, let's say, all the majors Linux operating system. Okay, so don't confuse SELinux to be, let's say, equal with an antivirus system, a firewall, or let's say an IDS or even an IPS system. So SELinux is created as a set of security patches for the Linux kernel. So it actually uses the Linux security modules in order to protect the system. So it's in the market since 2003, and it has been adopted from the version of the kernel 2.6.0. Okay, so the primary goal of SELinux is to protect not only data, but also services that has been compromised. Okay, so these are the SELinux modes. So we have three SELinux modes. We have the enforcing mode, permissive, and of course the third one, which is disabled, which, as you can see, it disables completely SELinux. So the other two modes, we have the enforcing mode, the default one, okay, which denies access in order for system services if they attempt, let's say, to read any file that has a different type context. So we will see in a few minutes the type context, which is SELinux Labels. So it denies access to a system service to access a file, a directory, or port, a remote file system in order to access files. Okay. Yes, so I have made a small mistake for that. Thank you, Mr. Luca. So the second mode is permissive. This mode is used for troubleshooting. So if you set SELinux in permissive mode, it will allow all interactions. Okay, it will not protect the system, but everything that happens in your system, it will be in the logs. Okay, so you can check in the logs what happens with SELinux. Okay, so traditionally, a Unix or let's say a Linux operating system, it uses discretionary access control. Who knows discretionary access control? Everyone? What is it? Actually, we are using permissions. And on a Linux operating system, we are using permissions for users, groups, and others, which they declare actually also the ownership of files and directories. So users can change permissions for their own files. Nobody will, let's say, they have actually their own permission to change permissions on their own files. Okay, so SELinux is a system which implements mandatory access control, and it's based on security labels. Okay, so The mandatory access control, which is, of course, as we've said, implemented by SELinux, is managed by a central authority. So it's not handled by the individual users that they use a Linux operating system. So you can see an example here. If I change the permissions on a file, or let's say a directory, if we have in place a policy preventing users or even, let's say, processes accessing that file, then we can say that we are safe. Okay, so we will see some examples in the end for that in order to understand what happens with SELinux. So these are the SELinux policies. Actually, we have two policies. The other one is not listed here because it's out of the scope for today. So the default policy is called targeted. So SELinux protects only the targeted processes. So the ones that you see here, SE status, get enforce, etc, SELinux config, are the ways that we can see the SELinux status. Okay, so let me do a quick demo on that. So let me log into my machine. So if let me log in as root also. So if I use commands like okay, sorry. Let me duplicate my screen. Yes. So if I use commands like SE status, what's the SELinux status? It's equal to enforcing. Okay, so the policy name is equal to targeted. So for the current time, SELinux only protects targeted processes. Okay. Of course, there are other commands like get and force, which you can, again, see the status of SELinux, or even set and force command in order to change the current SELinux status. So if I use cat etc SELinux config, this is the configuration file of SELinux. So you can see the three modes along with a small explanation. So the current mode of SELinux is equal to enforcing. So the other SELinux policy, you can see here the targeted, which, as we've said, is the default. The other is called MLS for multi-level security protection. As I said previously, this is out of the scope of today's presentation. Okay, so let's go back to our PowerPoint file. Now, the SELinux policies, a lot of people call them also SELinux context. So the SELinux context is simply a name that is used by SELinux. So the SELinux label or context always ends with _T. So files, processes, directories, ports, even the remote file systems like NFS, SMB, CIFS, also they have the SELinux labels. Okay, and the SELinux labels have the format of user, role, type, and the level. So for today, we are only interested in the type one. Okay, so the type label always ends with _T. Okay, so I will make examples at the end. Okay, so type enforcement. This is a part of a policy which permits a service that is running on our system to access files or directories, but not only files and directories, even the remote file systems and ports. Okay, so the Apache process, and we have, I will be presenting the Apache process because it's the process, let's say, that is exposed heavily, let's say, in the internet. So the Apache process, if of course SELinux is running in enforcing mode, has the SELinux label httpd _T. So then it can access files and directories under the var www.html folder, which is the document root for the Apache web server. So the HTML directory below var www has a different type context, which is httpd_sys_content_t. And of course, every process has its own SELinux label. Okay, so for example, the labels are embedded in the extended attributes of the file system. Okay, so for ports and processes, the kernel manages those labels. Okay, the others are handled by the file system, because the file system, once it's mounted, and let's say the SELinux is running in enforcing mode, then the SELinux labels are handled by the file system. So let's make some examples. So let's jump to my VM. Let's bring back the duplicate mode. Okay, so you can, let me first of all start my Apache process. So not every single command, but a lot of commands, they have an option which is called -z capital. So for example, if I use PSAU Z capital, and then I use grep httpd user:role, okay, and then you can see unconfined_t. Let me use also SSHD. Okay, let me check is running in enforcing mode, so something went wrong here. Let me use ls-z for my home directory. So the root's home directory has the SELinux label equal to admin_home_t. So let's take an example where a user has created a lot of HTML files and requires from the system administrator those files to be moved in var www.html. Okay, so let me quickly create an index file. So let's write this is a test, very quick example, and let's save it. So if I use the same command as previously, the index.html label for SELinux is equal to admin_home_t. So what happens now if I move this file to var www.html? Let's move it to var www.html. So if I use now for the option Z for var www.html, you see that the SELinux label is equal still to admin home t. But the var www.html has a different SELinux label. So if I start my web browser and try to access that file, so I will be using localhost/index.html. What happened? I get a forbidden message. I cannot access that file. Why? Does anyone knows? Because the index.html SELinux label is different from its parent directory. Okay, because we have moved index.html to var www.html. So if I didn't got any message. So we have some commands that we can use in order to correct that SELinux label. So one command is semanage fcontext in order to apply to a folder or to a file a different SELinux label, or we can use simply the command RestoreCon in order to reset the SELinux label of that file to the correct one. So if I use the command RestoreCon, I will be using the -r command for recursively, VV for verbosity, okay? And then I will specify the /var yes, /var www html index.html file. So RestoreCon has popped up the message which says what? I have reset the SELinux label of the index.html file below the folder var www html. Previously, it was equal to admin home t, but now it's equal to the correct one. Okay, so if we refresh the page here of our okay, doesn't work. So let me use -set /var www html. So now it's equal to the correct one. Okay, something seems that went wrong. My Apache doesn't work. Let me restart it. Okay, this is strange.
Cache response. If you do the private page with refresh.
Maybe our IT department is blocking.
No, I don't have internet access, so it should be working. Or maybe it needs internet access to work, but normally should work. But anyway, you can see that once you have changed the SELinux label, okay, then you will be able to access files. Of course, at any time, for example, the web development team, let's say, has created a folder. You can, at any time, if you have created, let's say, a folder which is equal to /virtual, let's say, it already exists. Let's make a /test. Okay, and if you use ZD for the /test, you can see that the SELinux label is equal to default_t. Okay, so how I can change that SELinux label for the Apache process to be able to access it? I can use the command semanage fcontext -8 to add, okay, and -t for the SELinux label.